Yeah.
So what I was thinking would be having hands-on.
Yes, very much. Okay.
So next time, tomorrow onwards we'll do.
Yeah, tomorrow.
Today we'll
Yeah. So if you are carrying a laptop, you can do that.
Can I have the phone? Here?
Oh, neat.
No, is it that?
Yeah, it's there. Okay, so and the notes will be found here for every topic that we'll discuss. I'll be putting notes over here. Every class or before class, you can check it out. Things. So this is, I mean, okay. Let's okay. Feel free to poke in. So of course, huh?
I didn't get my chapter.
Okay, that's a really good one. So we have three major categories of machine learning. So what is machine learning? Anybody wants to talk about it?
Machine learning is make your machine work rather than you give the machine some input, give them the test data, and it will predict based upon the actual data. That way, in a very high level, I can say. Let's say you are having take a sample and do some runs so that the machine will understand, and based upon that, it will find the optimized path. That way.
Okay. Anybody else?
In my view, if we have lots of data sets, some of them, those are anyway test data, so we can provide those. We need to prepare a model where we can throw those data into that. He will learn by itself, or we can provide some inputs into that, so that he will understand what is the input and what should be the output, so that it will be in future whatever data we can provide, no need to give anything, any input can give us the.
Still one very important one missing.
That is simply it is the interaction of machines with the user inputs.
Okay, one important one. Cool. So there are a lot of definitions, and a few of them are there. But the most important aspect in machine learning, right? Okay, that is what Tom Mitchell defined in 1988. So here the idea is the performance. Suppose you have a data set E. Machine learning is software M. Okay, and you have performance measure M. Okay, these are the three parameters. What should happen eventually is with every, with when the machine learning algorithm actually the software S, okay, works on the data set, then the performance should improve with time. Right? Performance of the machine, that means performance can be prediction, performance can be clustering, performance should improve with your execution, with the time, like humans, right? If you are coming from your home to this place, every time when you're traveling here, you're thinking, can I do it better next time? And you even, okay, maybe I can take that shortcut, I will skip that signal, right? That is what in machine learning in action, that is what a software does. Okay, so we are in a stage. Okay, I mean little bit. So now you know what machine learning is related to fish philosophy. I won't be spending a lot of time here, but yeah, you know this connection. If you look for, there is a book, Super Intelligence. If you anybody is fond of reading, feel free to read that book. What will happen, and you must have heard recently. So where I'm into the fact that software will be learning things. So what will it be giving? It will be finding better and better algorithm with time, right? This was typically human's job before, right? It was developer's job before to find better and better algorithm every time. But now your software is finding itself better algorithm. Okay. Now there is this book and there is this concept. Okay, and now going forward, maybe in our living time, okay, I'm not giving a dream. It might be reality too early that we can really expect. Okay, it might so happen. Okay, that all humans' work will be done by softwares, by robots. All humans' work. So that is the reason why Elon Musk was recently talking about this line that you want minimum income for everybody, because this will, you've heard about Elon Musk saying it, because that is what these visionary people, they think 20-30 years down the line, right? Bill Gates wants robots to be taxed because they will be the working. If you want that to work, yes. Okay. So So that is the situation we are getting into. Though our focus is not to get into the philosophy and why robots should be taxed, not taxed. But what I'm trying to say, this is more than reality as we are studying. It's more than reality. Okay, so that is what machine learning is about. Softwares that can learn, that can do things better with time. Right? It's not that same software will do, same 5 days down the line or 10 days down the line. You make him work, it will learn better. It will find some better ways to solve the problem, better algorithms, right? Use them, it will work. So that is how precisely you define machine learning. The notes. I think some basic classes have the notes that share that with you. Then there are 3 types of machine learning that we see. Okay. One is supervised. So what is supervised machine learning? Feel free to talk. Any ideas?
Supervised means we have to provide the input data to learn.
More precise.
It's like somebody will guide you and do it. Okay. Let's say every stage of your life, somebody will be teaching you, and based on that, you need to get out.
Okay. Yes. So in supervised, okay, the important fact here is you have the concept of labels. Okay, that means you have the data set. Okay, you have some labels corresponding to it. Okay, some labels. Like for example, you are doing some house price prediction. Okay, you have input parameters and you have final output of house price as well. Right. So these are labels or some information, right? Okay, which will be used in training the system, right? And this, suppose I tell you, okay, this is happening, this is happening, this is happening. So what are you doing? And I'm supervising you by telling you this is the input. So what you do internally, you find the suitable algorithm which will be a function which if takes this input gives that out as at least as close to that. That is your supervised machine. Okay. Then you have, there are how many categories of supervised machine learning are there? Majorly 2 categories. One is regression, one is classification. Right? Then you have unsupervised machine learning. I think I have notes for all these as well. Let's see. Some technical definitions. Infinity. We put in the same umbrella. Okay. So in supervised machine learning, we have given a data set and already know what our correct output should look like. Right? So you have the clarity on the output here. That is what the difference is. Having the idea that there is a relationship between inputs and output. That is crux of supervised machine learning. Then supervised machine learning are categorized into regression and classification problems. Okay. So we'll now understand how do you classify. See, first thing when you're given some work, you have to understand. See, it's very interdisciplinary branch. Okay, and you have to know maths, there's lots of things. But first thing is the thought process. How to approach the problem should be very clear. Because of that, when you're stuck somewhere, you're stuck at some logical sequence of execution. You're not stuck randomly anywhere, and you should be able to discuss with anybody. Because this is a place at least I don't know what to choose from. That is the discussion you should be able to have and should be able to understand. That will take you to the next stage. Okay. So first stage should be identifying the problem. Okay. Is it supervised or unsupervised? For example, let me talk unsupervised and unsupervised. Okay. Supervised learning, is it visible to all? All right. There is a way which I can make it visible. Actually, if I extend it, right? And if I right, it won't be visible here. Right? See. This is not yet counted by the way, but it won't be visible in the video, I guess. Yes. I'm not sure, but I don't want to extend it.
I will not know because we need the videos. Yeah. Sometimes if we forget.
We can actually change.
I think the earlier method was better.
Oh,
Just make it look good.
I don't know why there is this bug.
Yeah, this is okay. Not that bad.
I'll increase the font size a bit.
Only thing you will be getting all these notes, right?
Yeah, it is live. I'll just
Link you will just follow.
link I'll share. Maybe I'll just merge. Okay. So your supervised machine learning forms two categories. One is regression, one is classification. Okay, I'll explain what is regression classification. What you do in regression problem, we're trying to predict results which are continuous output. What is, for example, house price prediction? There is not really a label. House price is, this or this. It's like continuous output, right? Sales prediction, right? All this continuous output means what is there is two type of variables. One is discrete, one is continuous. Continuous 1.2, 2.2. I mean, it can be continuous values. Discrete means it has fixed sets, right? So when you have continuous values, it is regression. Okay, so tell me if you have to if you have to predict how many what will be the production of cotton this year? What will be it? It will be regression.
Continuous.
Continuous. It is a regression. First thing, should identify which type of data, which type of problem it is. Then the second thing is classification. Classification is the machine learning algorithm which actually classifies data. Right? For example, you are spam filtering email, right? What is the job of machine learning algorithm? To identify whether it is spam or ham, or maybe multiple. So if there is two type of classification, so you get two groups. Yeah, put it into some group, make it into different categories. So in that classification, then it will be discrete. Classification is discrete. Exactly.
So it's always a thumb rule, like continuous will always be regression and discrete will always be classification.
See, everything is a type of. These all are regression actually. Even classification is a type of regression. But what you do, and just very deep little insight from see. What you do, suppose when you are finally machine learning algorithm generating nothing but numbers, right? So what you do, if you want to convert a linear regression, regression algorithm to classification, if it is between 0, the range is between 0 and 1 output range. If it is between 0 to 0.5, it is label 0. If it is between 0.5 to 1, it is label 1. That is how the classifications happens, right? So that is internally. Okay, so you use logistic talk about it. So understood, right? What is classification? What is this? What is your regression? Okay. Map. So this is sunlight. In classification problem, we are trying to predict results in discrete order. In other words, we are trying to map input variables to discrete categories. Right? Clear, right? Then see, don't be overwhelmed by jargon. Jargon is a very important part of this thing, because when you are speaking to somebody, okay, maybe when you're consulting, when you're discussing things with somebody, jargon plays really major role. Feel free to poke me when things are not clear. Okay, I should not move ahead with assumption. This word is feel free. I think this part is clear, right? Yeah. So now, so there are these are few examples. Regression given a picture of a person, you have to predict the age and basis of a given picture. Is this it's written for here, but this is a regression problem. Everybody agrees. How it will be a regression problem?
In the picture, we have to predict the age. Yes, problem. You will be showing different pictures and I
exactly. So that is what you should do actually. When the way we learn, right? So how is entire machine learning was invented? It is actually neural networks, right? Or deep learning. They're trying to just map the way we are thinking. No rocket science. If you understand how humans think, you typically understand machine learning. So given a picture, so you are given a lot of pictures, right? Software is given, machine learning software is given a lot of pictures and a lot of ages of different. So you can plot a graph. Right? If that particular, how do you understand which pictures there with some topic, something or two later. So in pictures, right, you have corner points. There's a concept of corner points. Like you will understand this. If you take your picture, right, you will understand this part. There is something different in this part. You will put some dots here. Okay, so if you take, there are a lot of analysis that happen, but if you take your photo, eyes, it will be some nose, it will be some upliftment. You will understand that, and lips, it will be some difference. If you understand something which is decent, basic image processing algorithm. Okay, so that way it will understand that if there's old age, then the eyes may be a little lower, the width may be a little less. Right. So this sort of data will be used. Okay, and it will project graph, multi-dimensional graph. Okay, this is the parameters, this is what it is, and this was the age dot. Based on the algorithm which is modeled out of this. Okay, so when I will say models, I'll talk about it in a few minutes. Okay, when there is algorithm which will be regression algorithm, and what is the second category? Given a patient's tumor, we should be able to predict the tumor in malign or benign. Right? Categories, right? So what you have two data set. Okay, this is the size of the tumor and this is malign. This is the type of the tumor, this is benign. Right? So you have all this data set, then based on this you will get into categorization, classification. Right? So here I introduce you terms here. Okay, one is this is not the notes, maybe you can understand. One is dependent variable, one is independent variable. What about these terms? Dependent variables is your predictor or the x-axis data, which will be, suppose you want to find house price. Let me give the house price with square footage. The square footage will be your x-axis and house price will be your y-axis. So what is dependent with this x-axis data is known as dependent variables. Okay, the y-axis data is known as independent. This is known as independent variable. This is known as dependent variable. Okay, there are a lot of other terms. Explanatory variable. This is features. A lot of other terms I'll use as a. So. Okay, so this is your unsupervised. What is unsupervised? Where you have no idea about the results. See, in real world, when you're really when you're actually solving some problem, okay, what you will typically do is you will not necessarily it won't be the case that you have one algorithm, it will work fine and you get the results. You have to combine multiple. What do you say this word? You have to combine multiple models. So what are models here? So I'll use this term a lot, and in fact you will also use this a lot. So based on the learning that a machine does or the software does, it will create a model. Okay, what is this model all about? This model is all about creating a function. Okay, where the input variables are this guy and output is the outcome. Okay, so what is model? Model is just a function or a hypothesis that you use on slide, where it is also known as, because of historical reasons, it is also known as hypothesis. Okay, so what is model, hypothesis, function? All these three means the same thing. This means the algorithm which will predict the things. Okay, right? So coming back to our unsupervised learning, it has no idea how the results look like. Okay, what it does typically, it actually clusters the data. Okay, it just groups the data. Let's take an example. Clustering. Take an example of 1 million different genes. Find a way to automatically group the genes to group with someone. So it finds what the algorithm learns here, right? It finds the relations between data. Right? Rather than finding the relation between input and output, it finds the relationship between data and will try to bring that data to without having label information. It is also machine learning, so it is also learning things, right? But it does not have label information. Like it does not know what is the data, this is the output. It does not know about outcomes. It just knows what it typically does. It finds similarity. Suppose with four eyes, I want to make it into two groups. Okay, I'll find similarity. Okay, you two guys work in a certain way, maybe you can gel together. You two guys work in a certain way, maybe you guys can gel together. What I'm doing, I really don't know the category to which I'm belonging to. I'm tagging you guys to. It's mostly finding similarity between people and putting people together.
But this information will be provided to machine that these two are working in the same place.
Right. Some properties about you, some properties about him, right, and all the others will be provided to the software.
But not the outcome. From this property, he will understand, okay, these two are working in the same one, okay, make it into one cluster. The same for others. After that, we will do the analysis.
Right. So a lot of business cases. Any thoughts? How you sort of business? What are the other business cases? So it is used extensively by you.
It's like, let's say you are having 100 fruit items. Let's say one mango, one orange, one apple. So tomorrow I'll give you one more banana. Which group will get to put it? So it's like, okay, first I'll check the way you said that it's looking similar. Okay, the apple looks similar, the red and orange color is same. So I put it in one. Banana is completely different, say yellow color. So I have to put it in a different. So similarly, tomorrow, let's say one more fruit, let's say strawberry comes up. So it's another color. I need to put it in separate. So similar way, if let's say tomorrow peach comes up, then I can put it in the another.
Right.
So similar way of that is my thinking.
Right. So what do you do typically here? You find similarity among data based on how do you find similarity among them is a very complicated task, because you might be similar to him in various aspects, you might not be similar to him in various aspects. So it depends what are the features that is chosen. Right. So that this is, I mean, you suppose you want to find somebody's, how somebody is watching videos. Okay,
that way we are similar.
Yeah. So suppose my problem statement is I want you guys to go for movies. Okay, just an example. You guys to go for movies. So I have to choose. Okay, rather I want everybody to go to movie in pairs. Okay, so I have to choose which to have similar movie interest. Right, so I have to use the features which actually talks about movie interest. Doesn't matter now which sports you are interested. Okay, so
those inputs I need to see.
Yes.
Or those information will not.
No, because it doesn't understand. Okay, so you have to tell the features that has to be. Because the way you might be maybe totally irrelevant with the movies of today.
Yeah, we might be in the same genre, but he likes comedy movie, I like, let's say, thriller movie.
Right.
So there's no point in going together with a watching a comedy movie.
But again, there is some more relevance that if the movie has both thriller and what is the other comedy, then both of you may like.
Might be the same hero,
right? Yeah. Okay. So as you can, in fact, the smallest discussion, smallest example that we take, we see a lot of data points appear. Okay, so that is what. Essentially, how is machine learning trying to solve every problem? Okay, it is an iterative approach. Okay, what is iterative? It means repeating something again and again with different data sets. Okay, this is the iterative approach, and that is why I'll just talk about this. Hadoop cannot do iterative things. That's why Spark is coming. Okay, using Spark you can do iterative things, and machine learning needs iterative things. Some things need to be repeated for different data sets, same steps, and finding out what is the best.
So basically, in unsupervised learning, we just need to set before doing the algorithm. We just need to set some criteria. Based on that criteria, it will be like grouping all the data sets, whatever we are given, right?
Right. In all such algorithms, there is one parameter that we pass features. Okay, using features means if you take any data and write, you have that column name. Which all column name you are interested in using this number. By default, it takes all. If you want subset of it or not all of it, this is known as feature. This is our second topic. After linear regression, we'll understand how to use features, right? Because that is where the major task of the work is. Applying machine learning is very easy. But which all features should be used? You do permutation, combination of all the features.
So all the columns will be taking the
no, not necessarily. Not necessarily. So you might have to be a subset. You might have to say all. And sometimes most of data has thousands of columns is there. How do you find the best thing?
that is the question.
Continuously do it for all of them. There is no few things you can do based on your domain knowledge. That is why I say domain knowledge is very important. So based on your domain knowledge, you will short circuit few things. Okay, now in this few thing, which is if this is working fine, so there is a problem with using too many features. Because I will talk about it. If you use too many features, your algorithm will not be generalized.
Totally scattered.
Totally, it will be overfitting case. I'll come to that. It will be overfitting case, and it won't solve your problems, which is prediction. Okay, so there is a very Dixie-dicey situation, right? You have to choose. You cannot go too far, you cannot go too less, and you end up with issues. If you Google, this is a very classic problem. Cocktail party algorithm. Anyone heard about it? I'll tell you what the plan. I don't have videos recorded. I'll try to get one. What happens? Cocktail party means, a lot of people speaking. Okay, suppose you are talking to a friend over phone, or you're there and a lot of people are speaking. You want to separate voices. Or say you are singer over here, you're singing, but a lot of people are speaking. You want to record it. Okay, and you record it. What would it sound like? It will sound like somebody singing, a lot of noise in the background. Okay, what do you want to do? You want to separate it out. Okay, that means you want the singer's voice to be separate, the crowd noise to be separate. Okay, you actually do this using unsupervised machine learning. How? Because voice is nothing but representations of variables, right? Some decibels, some parameters will be there. That is how a voice is represented, right? Now, when you have that is one value. And the other category is, you see that voice is little suppressed in the background, right? So those values will be different. So if you really apply this cocktail party, this is standardized. Okay. So what will happen? You will divide the entire data set of voice, right, into two categories. One is your foreground, because the values will be higher. So it's very different, right? I mean, if you want to separate that voice out of this voice, you'll figure out that voice as some numbers which is common to that particular voice. Right? Here you have some category. You can actually break it down into two parts. Like now you have to cluster the data. You got to cluster the data. There are two groups. One is the singer voice, one is the audience crowd voice. Right? You can Google it. It's a very classic problem, very old problem, but people use it to explain these concepts. Yeah. He is coming from the deep learning, solves the cocktail party problem. So a lot of other things are there. The cocktail party is a phenomenon of being able to focus one auditory attention on a particular stimulus while filtering out a range of others. Okay. So this is a standard problem. I mentioned about it, but feel free to know it actually.
This is what clustering algorithm?
This is clustering. Okay. I mean, this is not really clustering, but it is like separating it out based on two categories. So
but it is doing like voice
processing. Yeah, it is.
Okay. Can be done in Python?
This is you pass the data. Maybe we can try this. Okay,
it is an audio file or how it is
audio file. See, no matter image, audio, it has some bit by bit representation, right? Finally, machine learning algorithm does not understand strings. It understands only numbers. Only numbers, right? So no matter what it is, just you need to tell it, how the numbers will be represented. Okay. So if you have the audio file, it will be compressed file. So you need an uncompressed version of course, so that your software don't have to do uncompressed, right?
So any other software you need to install for Python automatically take the audio file input
and you need uncompressed sound because MPG, this MPG, these are compressed version of the voice, right? So you need uncompressed. So you need raw file. Or of course, I mean there are libraries in Python which are using which we can develop compressed version. We can make audio players. We can. Right? What is the audio player? It is decompressing it and just reading it out. That is the audio player is doing. So there are inbuilt things in Python which are libraries like image. There is image, audio. Yeah, something I don't remember. But yeah, you have certain libraries. So you can make. So what is song? Right? It is that means somebody is decompressing your file. If you say 2.5 MB, it will be decompressed 55 MB. Okay, and reading it out. That is your media player is. Right? Any doubts so far? All right. I mean, remember this cocktail, problem. This is a classic. This when you are explaining to somebody, talking to somebody, mapping a problem, right? Map to this. Okay. So what are you doing? You have two noise. It separates out. Very good example. Maybe I can try sometime to get the recordings here. I mean, the separation after the applying algorithm and all that. Okay, although I mentioned it here. Okay, so we understood what is supervised, what is unsupervised. Now we have third type, semi-supervised, or sometimes it is called reinforcement, reinforced mission. Right. So what is the idea here? The idea here is, this is something it's not very popular, but I'll tell you what it is. So suppose you have some app which is a friend finder app sort of a thing, right? You're finding people. Okay? You reject someone. It will take the input. If it is reinforced machine learning, it will take the input that you just rejected someone. Next time onwards, it is using that as a feedback. Next time onwards, it will not recommend you that or similar things. This is like more feedback based, but you might think is very important, very important business case, but it is not really, because human behavior don't change then and there. This is the same concept, like you must have heard about on that Amazon recommendation. If you're watching some, if you're buying some product, you'll automatically it will automatically not start using that information in your next product. It will happen after a day or so. Okay, so this live recommendation, live things, right, that are semi-supervised, right? That is, it is using your live information to give you next data. But generally, this is not a valid, not a great business case. You won't see a lot of algorithms on this category. People say, this friend finding website, dating website, and also if you accept or reject someone based on that information, actually, it will be able to find, it will be ready to recommend you other information. But essentially, the thing, what has come out is, first thing, it needs a lot of resources. This live recommendation and all, a lot of resources. It's expensive affair, and human behavior don't change like that. It cannot happen one day you wake up, you're a different person. Human behavior is very static. So these are all behavior driven, right? So human behavior is pretty much same. You change, but it's a gradual process. Okay. So this live recommendation does not make a lot of business case. I know Microsoft is working on some products, but they themselves, the engineers themselves say, that does not make a lot of business case, because you're buying the product based on then and there. It tells people who bought this also bought this, like all those things. There is not really a point. Like only case where it really mattered was dating things, but that would be people like similar people every day, almost similar people. It cannot change trust. They don't drastically change. That is where there is not a lot of business case. But this category of machine learning is known as reinforcement. Right? Clear, right? So what are the three categories? So yeah, machine learning tasks are this: regression, classification, clustering, and dimensionality reduction. So the above three things we have understood, right? Okay. Now the fourth thing, dimensionality reduction, very important aspect. This is what what this does is, so as we're discussing, right, we have a lot of features, right? This dimension reduction helps you choosing the right features. If you are actually overusing many features, you might actually end up predicting wrong. So here, some bit of understanding here is, so I'll talk about bias and variance now. Okay, so so in case of dimension reduction, it tries to find out the best combination of features which will give you the best predictor, algorithm, right? Okay, so it will help you choosing the right features.
So this is again an algorithm.
Again an algorithm.
Okay. So before going to cluster, we have to work on dimensionality reduction. Then we will go.
Before we are working on other things as well. This dimension reduction is a very important part of the system, right? Because okay, we choose algorithm, we create. Do you really know those are the parameters that has to be chosen? How do you know that? How do you prove that? Okay, that is okay. Now, these few terms that we need to understand, so that we have to understand throughout that we have to find the best algorithm. Okay, it's not that something should work better compared to many others, and if you're good at that, you'll find the best among others. So you have to understand how to find which is the best algorithm, because it's not that you'll not get results, right? Every algorithm will give you some result. How do you know if you got some result? How do you know this is close to the best, better than the previous? How do you compare? Okay, so there few things are important for us. You'll hear this term overfitting and underfitting. Okay, overfitting and underfitting. So this has, linear regression will help me explain these two terms. Okay, but let's take an example. I'll use one slide so that I can show something. some slides that I will use the diagrams from here to explain linear regression. Okay, so feel free to ask. I'll share this slides. Okay, so it's a very a simple example to explain. Let me where I'm going. So you have this square footage size. Okay, you have this housing price size. Okay, and you have cross those areas which you have the data. But this is typically what I'm trying to explain now is linear regression. Okay, with one variable, then we'll explain with then we'll go to polynomial linear expression, then multivariable, and we'll now explore it. We'll start with one variable and we'll explore. Okay, so understand this one variable so that you can extrapolate others. Okay, so this is your data sets. Okay, size of house, price of house, cross these areas. Then supervised algorithm is of course where we know typically what is the right answer, and regression right answer. There are two types: regression and passive. Hi, are you? Am I audible? It takes a little time. Hello.
Yeah. Hello.
Yes, I'm audible, right?
Yeah.
Okay, perfect. I just I just shared. Actually, this video is getting recorded. Okay, so whatever part you have missed out, you can actually run through them. Okay.
Yeah. Okay.
Okay. So here I'm talking about linear regression. I just started linear regression. Okay, with one variable, I'm talking about it. Okay. So feel free to ask. If anything is not clear or anything is assumed. Okay, because a lot of jargons will be loaded in the entire course. Okay, feel free to ask. Okay. So coming back to it, what we have here, we have two data sets. I mean, one parameter here. So what is this? Square foot. This is known as feature. This is also sometimes known as explanatory variables. This is known as sometimes known as response. Okay. This is known as response.
All of these independent variables are called explanatory variables.
Yes. So there are a lot of terms you will see it. Okay. These are known as independent variables. These are dependent variables because the thing is dependent on this. Right. These are also known as explanatory variables. This is known as response. Right. So just to make sure. I mean, later you will get synced with that. So these are your various data sets. Now, because we do a little bit of maths here, so some notation here. Suppose this is your data set here. Okay, you have this size. This is the price. Okay, and what do you do? M is the number of training examples. Okay, X is the number of input variables features. Okay, and this guy is X. This is known as input variable of feature. You can of course have you can of course have okay. So you have these are the ways. So we have only one feature in this entire experiment. First experiment, we're taking just one feature. Okay. And how do you write those features? Okay, Y is your output, X is your feature, Y is your output, and each training example. Some notation here, please take into consideration because we'll use it in our algorithms. X and Y. Okay, X and Y is each. This is X, this is Y. Okay, and X I Y I. You're able to see this, right? Okay, this is like ith training set. Clear, right? This is ith training set.
What is the type?
Ith is number 1 0 0 1 2 3. Like X1 is 2104. Y1 is 460. Okay. Clear, right? Okay. This is the diagram I wanted to show. So what we have here, we have a training set. We have the learning algorithm. Okay. What is the outcome of this? Hypothesis or model or function. Whatever different books refers. Okay, this is first history. Here it is H because of historical design. They say that people when started they used H. Okay, so H is for hypothesis. Okay, so after, yeah, H is the hypothesis. Okay, during the entire, after the learning algorithm has used a training cell to propose a hypothesis, okay, then you will give a house size and it will estimate the price of houses. Okay, that is how the system is. Okay, give a new house, it will estimate the price of it. Okay, so yeah, now a little bit of maths here. Okay. See, okay, so we are using set. What are you trying to do using it? Using linear regression, you're trying to find relationship between response variable and single explanatory variable. Okay, single explanatory, single feature independent variable and response variable. That is a relationship we want to find. This is known as simple linear regression. Right?
So everywhere you have put the jargon around it.
Yes.
We can say it is a
one-to-one relationship in this case. So yeah, so you're trying to find the relationship between response variable and single explanatory variable. Now let's see. Okay, so if this is the situation, the simplest way to do this is you see this theta. Okay, it's really simple. Okay, just be little patient for a little while. Here. So h theta x is the prediction. Okay, h theta x is the prediction. Y, right? Okay, but y is a different term here. So just use h theta as a prediction. Okay, because if you remember. Okay, if you remember in the algorithm, y is your actual value. These are not predictions, right? These are your actual value. So I will name actual value as y, prediction value is h theta x, right? Actual value as y, prediction value is h theta x. Okay, so okay, or it is sometimes known as hx also. Okay, but so h theta x will be theta 0 plus theta x, theta 1 x. If you remember, our maths, y is equal to mx plus c, right? So y is equal to mx plus c. What is c? Constant. That is intercept, right? In a graph, if this is, suppose if the line is like this, okay. Suppose if the line is like this, c will be this guy, right? Intercept, and the line slope will be m. Right? So similarly in this case, this theta 0 is intercept part of it and theta 1 is the slope of that line. Okay. So what is theta 0 plus theta 1 x? This is a line, straight line equation. Right? Okay, this is straight line equation. So now this is linear regression with one variable. Okay, we'll show more things here. Okay. So what you're trying to do here, understand this. So based on your current learning set, based on your square footage, okay, and your price, you are now predicting the you're predicting a line. Okay, that so how many possible lines can be there? Any number of lines can be there, right? You have n number of lines. What you have to do, you have to find the best line which could be used for future prediction of house prices. Clear, right? That is the, if you have single variable, keeping things very simple, you can have how do you have different type of lines? You will have different type of lines based on the value of intercept, right? And m. See, I mean, if you are very new to this y is equal to mx plus c, this is how you define a line. Okay, y is equal to mx plus c. Based on different m and different c, you will have different lines. Right, so here m and c are nothing but theta 0 and theta 0 and theta 1. So based on, so how one line can be different from one line by having different value of theta 0 and theta 1. Right, so you might have a lot of lines. So how do you find which line would match the case? I mean, which is the, how to define a line? It is defining theta 0 and theta 1 typically. Right, so what is our job as a machine, as an engineer? We have to find the best line which could represent our data. Now we'll use scikit-learn to at least get started with this. Okay.
Our main intention is to find out theta 0 and theta 1.
Right.
You have written theta I.
Yeah, theta I. Right. Theta I is both.
Okay, so in this linear regression,
Hmm.
we are planning to get that best fit line.
Hmm.
Once we get it, whenever the next question comes,
Hmm.
it will use that best fit line to find out the
Exactly. So for example, and we'll do it now. Okay. Suppose this is the line which is predicted, and suppose if user is giving a price which is here, so what will be the prediction price? It will be this way. Okay. Okay. So what do you have to do? You have to find the best line. Now the question is, okay. Now the question is, how do you know something is better than other or not? Right? You have two stuffs. How do you really know? You know this line is better representation of your data than the other. For that, you have something known as cost function. Right? Using cost function, you'll figure out whether this line is better or that line is better. Right? That is this. So these things are not specific to only regression. This will be specific to quite a few of things. But in unsupervised, it will be getting little different in classification. It will be little different. Okay. So to find the best line. Yeah. Now just see this case. See this case. Okay. So what is your final objective? You have to find theta 0 and theta 1, right? Okay. And how will your software identify? It will test it for all theta 0, all theta 1. Right? I mean, forget about the other side of the story. What is the best way to figure out which is the best theta 0, theta 1? Just try it for all. Right? It's a brute force process. Okay. And during that process, suppose it is actually, and why this machine learning can do things in parallel, because one task is independent of other. You can actually put them in different machine, get the result, and do the merging part of it, right? So you can now realize, right, why Spark or this distributed computing and everyone was such a boom for this stuff, because you can parallel do a lot of process. Okay, let's take an example of this first.
One of the points are interdependent.
Everything is independent, right? So let's take one case where theta 0 is 1/5 and theta 1 is 0. Do you understand why this is a straight line? Because the slope is 0, right, on the constant case. So this is a straight line. So what if suppose you take this as a house square footage and price, it means no matter what the square footage is, the price will remain constant, right? I wish that was the case. So. But in that case, what is the problem? This would go very high, right? the intercept will go very high. So again, that will be out of reach.
no one will get the land
because everybody is exhausted, right? And apparently it will be straight line, but the intercept will go higher and higher, right? So it will be out of reach that. Then the next equation is where the theta 0 is 1. Theta 0 is 1 means intercept is 0. Intercept is 0 starting from the center, right? And slope is 0.5. So with house price going double, square foot is going double, it will increase by 0.5 and half of the things, right? So this is why the slope is like this. Okay, so if you are figuring out, this is the best, combination of theta 0 and theta 1. Next time onwards, you given a house square footage, you will be able to predict the house price. Similarly, the third line. So. Okay, so I'll come to this. Okay, first I'll show some scikit-learn. Okay, so what is scikit-learn?
machine learning model.
Perfect. So scikit-learn is machine learning model. Okay. So this code, I'll be using this IPython so that everything is visible, and this is uploaded in GitHub also. So you should be able to. So we have, a similar example. I just took the example of pizza. Okay, size of pizza and cost of pizza. Okay, just I change something so that we can agree about it. Okay, so I believe you guys know a little bit of matplotlib. Just a little bit, not too much details. Even if you don't know, it will actually be self-explanatory. Okay, a little bit of matplotlib. Okay, and I'm using little pandas and numpy to represent data. Okay, let me know if some things are not clear. Feel free about it. Okay, so what we have here is we have data set here. Okay, this is the size of pizza. This is price of pizza. I will put them together in a pandas data set, right? Then I'm trying to print that data, print the mapping here, right? How am I doing it? So m dot min is magenta, I guess, right? The color, right? So that is why. Can you see it actually? Yeah, you can see it. Mint is a font. Much better, right? So this is the title. This is the X label, Y label, and here this is my pandas stuff, right? So pizza size, I'm getting that particular column. This is the price. This is pizza size. This is the price, right? And I'm plotting it. And this is my dimension 0 to 25, 0 to 25. And grid wise, that's why it is showing in grids, so that we can easily comprehend it. Okay, so this is my current data set. Okay, so now I want to apply simple linear regression, as we just understood, okay, on pizza data to predict prices based on size. So from sklearn.linear model, okay, I mean, if we were carrying a laptop, I would recommend you to, from tomorrow onwards, do that actually. Just do it once and it will be, hardwired. Okay, so sklearn linear model, linear regression. This is the, linear regression. So what I'm now creating a linear regression model. Okay, so what is this stage doing? Okay, so what is this stage doing here is this is creating, if you remember the diagram, this is actually this will be algorithm predictor. Okay, this will be algorithm predictor. If you remember this diagram, so that whatever linear regression that is returning, what that function is returning, something we can predict this linear algorithm. Learning algorithm, right? So what is it is just creating in place. What is required to create a learning algorithm? Data, right? So you need to feed a lot of data as you're doing here, right? Only that will make it capable of creating. Only that will make it capable of creating
This learning algorithm will do the estimated time.
This learning algorithm will be no, not really actually. So this learning
it will run on every point. So every point it will create one like this, right? That is the
hypothesis, I think
it will create. See, this learning algorithm will take data, okay, and it will create a function, hypothesis. Okay, so just suppose you have seen this case. You have this point, this. So one possible line is this line, right? Okay. One possible line is this line. Okay, so and one possible line which is going through this. Okay, one possible line is middle of both of them. Okay, so these are possible three lines. Right? These are known as hypotheses. Got it, right? So what is that function returning you? This linear expression. This is giving you learning algorithm. Right? Okay, and now when you are in the learning algorithm, when you are passing data, right? It is finding you the best line. I'll come to that, how it is finding the best line. But what is this linear regression doing here? Comment here also. This is giving you the learning algorithm. Okay, because, and what is this learning? This is learning algorithm based on linear regression. Okay, so it created a learning algorithm. Now what you need to do, we want to train this learning algorithm, right? So that it finds the best H for a best hypothesis for you. Okay, so here it is training the algorithm. Training the model so that it returns best mod slash. Right. So what is the first thing that you are giving here? This is the model that is returned in the first linear regression, right? So what are you doing? You have, I mean, almost the APIs will remain the same. You have fit here. Okay, fit. This is the input. Okay, this is the input price. So you can see here I'm giving some this double bracket. Why?
That is very
Yeah, data frames. See, actually this is common throughout. Okay, so now when you are giving data to this pizza price model, right, you're getting data from this data frame and you're giving the data here. It actually accepts data. See, in this case we have only one feature, one experiment. If you have multiple data, you write size, comma, multiple features. So it actually expects you list inside a list, right? Because the inner list will be all values of all the features and the total collection will be collection of all the data. Okay, that is why we have to give it like this. Yeah, right. Similarly for price.
Linear regression is a function.
Right.
So based on the parameters, whatever we are given, like for example, x and y axis, public or y coordinates, based on x and y coordinates, it will create the same set of data like hypothesis, or it will only structurize the data.
No, it will create hypothesis here.
It will create.
See, in this case, it is a blank model initially. Okay, blank model. Now it is training the model. Training the model means it is trying to find out this model will itself hold the. See, what does a model consist of?
Here my doubt comes. See, normally that mx plus c is an intercept. Interceptor comes around when there is an angle separation in the linear line with respect to our 0,0 position or with respect to constant line.
Right.
Theta should be there, right? Based on that theta, cos theta, we should define it.
Right.
So how we are defining the interceptor here?
You are asking with this line only this line. So in this line you are not actually training the system. There is no data that has gone in this line. It's just a blank model image. Because see, finally this is a software now. You first create a blank model, then you train it. Okay. So now that you are doing a fit here.
So basically based on the blank model, the linear line should start from 0,0.
Yeah, you can imagine that. Okay, but it does not really matter because it is blank learning. I mean, there is no learning here. It is as good as a new baby is born. It has no understanding, so you cannot use it to predict things or analyze things. Okay, so it is empty here. Nothing is there.
Like built-in functions are available, and we need to use them.
We need to use them. Yeah. So this is nothing. This is just creating a placeholder. You can imagine, like before using an object, you initialize an object, you allocate an object. This is like object allocation. Returning learning algorithm object. Okay, no learning done here. Okay, to avoid oops. Now, okay, so what are you doing here? You are training the system. You're training the system. This is the input, this is the output. If you have multiple features we are training, you have to be comma separated in this case itself. That it will take as multiple features.
So here you are giving both input as well as output.
Because training needs both of them, right? You need input as well as you need output.
Because regression.
Regression, right? Okay.
If you have been clustering, then it would have been different.
It would have been different. You don't need to give. Okay. So it is understanding it now. Now with this stage, right? With this stage, your model is ready now. Okay, if you do this. So let me execute all of them. Oh, just give me a moment. So yeah, so let me execute. See, this is importing. This is creating a linear expression. This is creating a process. Okay, now insert cell below. Suppose, coming to your question, is a price model. Right, so these are various coefficients you will see actually. Now it's a simple equation. As we complicate it, like if you want to know the intercept.
Okay, on all the data points, finding the intercept rate.
See. You have different
Right.
cross.
Right.
You have to find the best line which is closest to all the cross.
That is fine. But when you put the dot intercept,
Hmm.
let's say you are having x input and y output. X1, y1, x2, y2, x3, y3, like that, you are having 10 ones. Yes. So when you put the intercept, after this model regression, it will show you the intercept in first case plus 2, second case 0, third case.
No, intercept will be one only because there is only one line.
No, that is the final answer is only one line.
Oh, you mean all the
Intermediate answer, yeah.
Oh, intermediate answer it won't show.
It won't show. That was my goal.
Okay.
I thought it will create table and after that only you can see that those data and best fit line will show there.
Right. So that way we have to do it manually.
Okay.
Right. These are APIs. So the objective here is to give the best straight line for it. Okay. So it will show only the best results for you. Okay. So now that your model is ready.
So now see, what is the final regression?
Yes.
Post regression.
Yeah, post regression. So it found out for the certain test cases. I'll now explain how did it find out, because that is interesting. That is the point we need to understand. How did it find out which is the best line here? But you saw one case, right?
And how can we justify it? But whether it has given
Yes.
the correct course or not?
And I'll show you that. So because it has to find out the best line. Okay, let's now understand how to find the best line. That is the cost function I'm talking about. Okay, so what is cost function? Till now it is clear, right? I mean the step by step, right? Let's see the cost function. Now coming to this equation. Okay, so here we have here we have to find out which is the best line. Okay, how to do it? Forget about the maths. Okay, how to do it? Fundamentally, you have the line. Then what you have to do? You have to find. And before that, actually, before we find, is this algorithm better to other? How do you test somebody? So if you have to find out which is the best line. Okay, suppose I have to do testing. Suppose all of you are taking up maths, you learned maths. Now suppose I want to test you. How do I test? Suppose we have in the course we studied a lot of maths. Okay, solve a lot of exercises and all that. Now I want to test you. Test who learned it best. How do I test?
Exam.
Give the same example to everyone.
Should the exam paper be same as that we used in learning? No. Very important. Very important. Exam paper should not be same. The test should not be same about, because we that way everybody can memorize. Right? Then that person is not good for future new work that will come. Understood the point, right? So that is the reason. Okay, we have to divide the data into two parts. You have to divide the data into two parts. One is right. One is training set. Okay. One is test data. Test set. Okay. So there are many ways to do this. You have the entire data set. You use random spread and those things to break down your 80-20 ratio. Okay. Suppose you have done that. So that is the importance of. Remember, your training data should be as far as independent of your learning data. I mean, and your test data should be as far as possible from your from your training data. Okay, and yeah. Now, what you typically have to do here, so you created multiple lines. You figured out multiple lines. Now to find which one is better, what you do, and you figured out this multiple line based on training data, right? Now what you have to do, you have to find your what you have to now you use test data. Okay, you use test data, and you will find out the difference. See this diagram. Suppose this is the line that was predicted. Okay, h theta x is the predicted value. Y is your actual value. Understood? So your training set will be given x comma y. Y is your actual value. H theta x is the predicted value. Clear, right? Okay. Now, suppose this is the line that was predicted. What if, suppose for this value I, for any value I, so yi is your actual value and h theta xi is your predicted value. Clear, right? Correct. One is your actual value, one is predicted value. So what you do, you find the difference between predicted value and actual value
On the current data set, on the training data.
on the test data set. That is how you will test, right? Because you have to test that particular software. To use that to learn, but you have to test whether that particular guy has learned it well enough or not, right? So you use test data set to test. I mean, that is how internally it happens. Okay, so you will give test data set. Okay, and
The remaining 20%.
Yeah, remaining 20%. Okay, and we'll see how to find how to measure that. Okay, but you gave that test data, but what you find out. Okay, so what you found out the difference between actual, for all the data points, actual data, actual value of it, and predicted value of it. The difference is what? Difference is your discrepancy or error. So what you do, you square all of them. So now you'll ask me, why do you square all of them? Okay, mean square, yeah. So you just square them. You square all the differences. Okay, why do you square? Two things. First is, when it is negative, it is making it positive. If it is a number, it will make it bigger number. So your errors are more highlighted, differences are more highlighted, because that is what we want. Then you do a root of, so you find sum of all these things, you do a mean of them. So you find the mean root square. Okay, then you do a mean square. Then you do a root of it. Okay, that will be your RMSE, root mean square error. Okay, this is your cost function. Okay, this is the value which will tell you whether one straight line is better than the other or not. Okay, this is the value which will tell you one straight line is better than the other or not. So what you will do, you will find all the possible lines. You will find RMSE for all the possible lines. Then you will see which one is the best.
That is during the testing. That is during the testing.
What happens? I'm answering the questions I want to ask. So what happens in the training part now? In training part, how are you learning which algorithm? In training process, you're proposing one algorithm, right? How is that algorithm proposed? Based on whatever lines it chose, and it did all the processing on those training sets. It found training RMSE, right? Training RMSE is one number. Like whatever train data was given, and it predicted that line. And on the training RMSE is training data, it is finding training RMSE, right? That is the number it is. Okay, I have learned to complete the syllabus, and all my self-assessment, I think I am doing this. That is that number, but that is not reality. Because it is using only its training data set. It may so happen the training data set is skewed. Skewed means it is one-sided. It is not fine. It's not generalized, right? But if the algorithm is not able to understand the intricacies here, it will learn based on, it will memorize this. So this is test and memorize all the numbers. It actually happens in software, right? It will memorize the data. That is overfitting. Welcome to that. Okay, so yeah, so it actually memorizes. This is the training data set. So when an algorithm is proposed, right, it will tell you, okay, this is my training data set, and I am this much. I am this much. My RMC or my cost or my score is this much, right? And now to actually test it, you will do with different data sets. and that will be the confidence. Is it clear? How a training function, or say in our case linear regression, how it is proposing assume that value of intercept, that value of slope based on all the lines that it is tested, right? Based on all the lines that it has tested, and based on lines that is tested, based on the lines that it has tested, okay, it will create its own RMSE, and it will tell you that I have learned with this RMSE, and you will test it now with different RMSE, and the job will. Understood the difference, right? Between the testing training data set and the testing data set, the differences.
Okay, my doubt is here. Okay, we have suppose 10 points, and using those 10 points, maybe we can draw 50 lines, different lines. To find out the best fit line, we have to calculate RMSE for each individual lines, and which is the lowest one that we have to take.
Yes, that software will recommend.
Okay, yeah. So that is the best fit line we got, and when we are testing with the test data, we have to use that best fit line only. We don't have to do any other lines. Since whatever line that best fit line is. So if we are getting the X value, we'll find Y value using that best fit line only, which may or may not be the same or maybe nearer to the actual value, and that will find out the confidence.
Yeah, I'll just add a few things here. So now, suppose this is one feature. Okay, suppose you have multiple features. What you can do? Just a very simple example, which will actually clear if there is any doubt. So you will have different features, two feature one time, two feature another time. You get two different best fit lines. Now you will give both of them the same test case, the test data which is not used in training, and you will find out, okay, what is the RMC now, and based on that you will figure out which is better than the other. Got it, right? Right. This just cleared everything. I think. Is there any doubts in this area? Clear, right? I mean, have that thing very clear, because it will extrapolate. I mean, whatever understanding you will have now, it will because n dimension, which is having one data, will be either plane that will be drawn, right? Clear, right? One person doubts.
Could you please once again tell it, because I was not able to understand.
Okay, yeah, feel free. So see, now whatever, suppose in the code, right? That code is the best way to understand two things. Suppose in the code, in here, it created best fit line with the parameter size. Suppose you assume that there is one more parameter, toppings. So we in the next model, what we did, we pizza toppings. So one line was created using size, one line was created using toppings. See, two different features. Okay, so two lines are there. Now you have to find which is the better line. There can be more cases, like you can use both of them. Like let's say two features. Let's have size. Let's have toppings. So there are three possible combinations here. Okay, one is the model using size. One is the model using toppings. One is the model using both size and toppings. Right. So you created three models. You found the best fit for three. Now you have to find out. That is where your developer's jobs kick in. You have to find out which among these three is better for you. Right? So the easiest way, this is dimension reduction, it's different, but the easiest way is you will have the test data set, and you will pass the test data set here, and it should tell you, what is the RMC now, what is the performance now, and that will be your answer.
For all three?
For all three, you will get different model, right?
Yes.
Okay, for different model, you get different test data. Yes. If you give different test data, you will get different RMC.
Yes.
Right? A different test data means same test data to all of them.
Yes.
Right. So you'll get different RMSE because the model is different, and based on which one is performing better, you choose that.
Yes.
Right. Got the picture clear, right? Okay. I'm not saying this is the way it is done, but it is definitely helping you find out.
Which one? Let's say after 3 RMSE, which one will choose? Straight upon the requirement?
No. Which is better to closer to 1?
Oh.
Okay. See, RMSE it should be closer to 0 actually. Okay, but here in Scikit-learn, it is done 1 minus RMSE. So it should be closer to 1. Got it, right? Your root, what is the best line? Okay, now is the best time to introduce overfitting case. What is the, so as of now you just saw a straight line. Okay, if I use quadratic equation, like what is the quadratic equation? Right. I think I have a quadratic equation in my here itself. Suppose not this is. I mean, this is manifesting. This is quadratic equation. You can see this, right? Ax square plus bx plus c. One way. So when you have one x square, it can give curves now.
Okay, before going to this, sorry to interrupt. The previous one,
Multivariable.
multivariable. That is the example for pizza and topping.
Multivariable. See, that is little different here because I'm using different features here.
So
Pizza and this thing is y is equal to mx plus c.
no, pizza. No, the example you
toppings.
toppings.
Right. Very true. So if you have toppings, I'll come to that. Suppose you have various toppings, so you can use two variables. This is your size. This is toppings. So what you have to find? You have to find beta 1, beta 0, beta 1, beta 2, 3 variables. Right? Okay. Now now you can have a curvy line. Okay. So this is ax square plus bx plus c. Okay. Similarly, if you have 10 points, zigzag, you can actually figure out using this. You can figure out the line which actually connects all of them, right? But so what is the understanding you get now that if you have to find the best line, I mean, not now that we are not restricted to straight line, it can be zigzag and all the various curves are possible. You have to find the best line. How do you really what do you say? I mean, if there is a line which touches all the points, is that the best line?
Yeah. It will touch
all of them. Then what is RMSE? 0.
Yeah.
Because the difference between 0 and 0 is, I mean, y. There is no difference between y and h theta x. So great, you learned a great line. But what will be the score? What will be the prediction on test data? Score. I will just tell you what is score for a minute. Okay, just give me a minute. Score is 1 minus RMSE. Okay, RMSE is right. So let's see.
So RMSE should be nearer to 0 and score should be nearer to 1.
Yeah. Okay. So evaluating a model, just show the one output actually. See this data. Okay. So this is RMSE. This is score. Score, just have it in mind. Score is nothing but reverse of RMSE. 1 minus RMSE. Okay. I must have written it somewhere. Just a second. Here it is actually. So evaluating a model, right? If you have to evaluate a model, it's going to stack it there. What do you do? This is the data set, right? What is this? This is test data, right? And here, what are you doing? You are evaluating this model, whatever you predicted above, right? You want to evaluate. So this is my test visa. The data is different from the one that we use for learning. There may be little overlap, but the idea is it should be different. So now that model is now evaluating at 0.59. Okay, so it should be closer to 1, so that it is a good, good is a trained system, trained algorithm. Okay, this is one data here. Okay, score. So now, okay, so
that score is showing 59%.
0.59.
How to? Yeah. Anyway, it is. So how to increase that?
Yeah, how to increase that? See, so now you realized you have created a model. When you see, square is part of evaluation, and you are evaluating a model, right? So if you have created this, then you realize you have taken size into consideration, right? So you might think, okay, what was I talking before this? Where I came from? Just missing that. Before this, why I came to evaluating?
He was asking about the multiple Topics and
Overfitting.
Overfitting. Yeah, I forgot what was the starting point. Yeah, overfitting. Okay. Now, if you see, the score is less here. Okay. Now, if you create a curvy line, I mean, some line which actually touches all of them. I think I have this slide. Yeah. Suppose this is your data set. Suppose I have the diagram here. Okay. Suppose draw it somewhere. Okay. Let me show a diagram which is from the data. Suppose your data set is falling here. You can see this line, right? Your data set is falling in this line. Okay. Suppose it is falling here. So if you figure out a line which is touching all the points, then it becomes like this, right? All the points, because it is, you can actually create an equation like that. You can create a function which will generate a line like this, but it won't be power of 13th, x raised to power 13, that sort of thing will be there. Got it, right? A plus bx plus cx square plus dx cube. It will be to the power 13, then the line will be very, very curvy and it will touch all the points. Okay, so what will happen? The RMS is 0, but not the cost function. Why? Because it might be, a lot of convoluted stuff. Okay, and now when you are actually using it, so what is that line? That line is not generalized. That is overfitting line. It is overfitting all the cases. But when you are giving it new test data, like to find the score, it will do bad, right? Because the sense of generalization is missing here. It is trying. It will not solve the purpose. That is the problem with overfitting. Okay, and what is underfitting? Underfitting means it actually it's the RMS is just skewed up.
Like this.
Suppose this is the line and the data is here, straight line. That is underfitting. That is not the best way to predict, right? The RMS itself is so you should not do overfit. You should not do underfit. Okay. Now understood, right? What is overfitting and underfitting?
So in this case, cost function is to find the score.
Yeah, score is to find the cost function.
So score is to find the cost function.
Right.
So 1 minus IMC is the score.
It's just a way to represent it in Scikit learning. Okay.
So our main intention is to find the score.
Yeah.
More than 50% score is as long as score is towards 1, then our model
is doing good, right? And remember, you are finding score with respect to only test the data set which is not used for training. But if suppose if you use the same data set that is used for training, you'll realize that it is 1 because you gave the exam same question paper that was taught to the student, right? So your test data set should always be different from your training data set. Clear, right? Okay.
I have one question. The cost function we are saying is that y equal to mx plus c, that function we are saying, or
no. Cost function is RMSE.
RMS.
Right. That is cost function. That difference. If you see the pictorial representation of it, it is this function. See, this cost function is what now let me explain this thing, which will make it. So until now it is clear, right? Okay, that means so now you have to find the best combination of theta 0 and theta 1. Okay, which will minimize 1 by 2m, which will explain what it is. Sigma of what is this? I is equal to 1. Sigma of I is equal to 1 to im. That means for all the line, all the test cases, you are doing h theta x. Okay, this is your estimated one based on the model that is chosen, minus yi. Okay, and you're doing a square of it, right? So you have to 1 by 2m is it is a constant factor, 1 by 2m. So constant factor over these things is to simplify the calculation. Okay, it does not have any result on the curve or the prediction values. This is a constant 1 by 2m. M is the number of test cases. Okay, so that's why it is going for I to m, right? For each test cases, it is finding this difference. What is this? H theta x, H is a predicted value, y is the ith value. For each test case, it is finding this, doing a square of it, adding the sum. Right? So for each model, it will get this data. Each model, each value of theta 0, theta 1, it will get this data. So what is the cost? What is the function that will be chosen? That the function that will be chosen is the case for which the entire result will be minimized. That is why it is written minimize theta 0, theta 1. Right? Because that is your final objective. You want to minimize the value of theta 0 and you want to minimize the entire stuff, okay, and find the theta 0, theta 1. Clear, right? So that this line is clear. This line. What is the objective? You have to minimize this entire thing for theta 0, theta 1. So you have to find the best combination of theta 0, theta 1. So this is only two variables here. If you 3, 4 n variables, it will be theta 0, to theta n. These are number of these are number of features plus outcome. Sorry, number of features. These are your coefficients in y is equal to mx plus c, a, b, like all those coefficients are there, right? A and c, and c, yeah. M and c, right?
So this is the formula to find out what?
This is the formula to find out the cost function for each case. For each case, and you are finding the minimum theta 0, theta 1 for which the cost is. This is the cost function. Okay.
If I split R and S E, so root means square error. Okay. So this is square.
This is square. Yeah.
Then we have to mean it. Then we have to.
So see, he is actually doing a sum of it. This is 1 by m, right? M is what? Number of test cases. What is this? Square.
Yes.
Right? So what do you do? This is difference between predicted value and current value. Right? Predicted value and current value. You are squaring it up. Right? So then remember the predicted value, the predicted value and the current value. Right? You are finding the difference here and squaring it up. And you're summing them. For a particular line, you're doing a summation here. So summing all of them. Right? And after that, we're dividing by 1 by m. 1 by m means it is mean now.
Yeah. Okay. Why 1 by 2 and then?
I'll come to 2. So now what do you have to do? Square root of it, right? Okay. So if you do square root, it is very difficult to do this differentiation. This actually is differentiation. Calculus will come into picture. Okay. So for simplicity, it is done by 1 by 2. That means in place of square root, right? You will just by 2 because you have to find the best length. Okay, so it doesn't really matter.
Root we are using 1 by 2.
Right. It's just for simplification of the algorithm because it doesn't matter really because number whose square is bigger than the other number, the one square root or also will be bigger, right? So what do you have to do? You have to just compare a cost. Okay, you have to compare cost of two lengths. So what it calculated the square and compared the value. Right? So what you have to find which one is better than the other. That will be sufficient itself to compare which one is better than the other. You really don't need to do square root again.
Okay. But if you are saying that 1 by 2 and square root are almost same, practically it is not same, right? Means 3 square is 9, but 9 by 2 is 4.5. So how it is?
It is same in a way. Suppose we found two functions. Keep asking those questions. Suppose you have two functions. You calculate your model, you calculate your model. Your model is 25, his model is 36. I have to tell which one is better. Do I really need to know the square root of both of them to compare which one is better, or is this information sufficient for me? Sufficient. Right? Because
that is its score.
Because this is used for nothing but comparison. Right? I have to compare both the models. So if the square root is fine, so a square root is available to me, I don't really need square. I mean, square is available. Do I really need square root? No.
Yeah, but the score is calculated by this value, and if we are doing something wrong in the calculation itself, the score, whatever score it is we are getting, that may not be correct. Right?
That may not be right, but that will be sufficient enough to give you the right information. See, suppose I mean, to nullify that, actually 1 by 2 is there. But anyway, suppose you have square value. Suppose you have a model whose square value is 36. Just checking it. The score value is 36, and you just did a square. Okay, you have, as a model, I have that information. Your value is 36. I have this information. Your value is 25. Will I be able to tell which one to pick and which one to not use, which one to use and which one not to use?
You have to take whatever which model score is better. Yeah. You should not be going into the depth.
No. See, as a person, right? As a system which is supposed to get the best model, right? So I have your data. I have your data. So am I in a position to decide? I have the square values. I didn't calculate the square root. But using square values, will I be able to tell 100% correctly which one is better? Well, see, the result is root of this thing, which is mathematically defined. Okay. Now, root of this thing, suppose the value so far you calculate 36. That's okay. He calculated 25. Now, for me, technically, mathematically, what is required? Root of your value, root of this value, right? But root of this value is like root of your value is 6. Okay, now I realize, okay, you are better. If I don't do square root, will I be still able to tell? 36 is of course greater than 25, right? So the relationship is always true, right? A relationship, okay. The relationship, okay. So if 20, you have, suppose his value is 25 and you have 36. So this is a relationship, okay. Then because this anyway will be positive, right? I mean, there is no question of, because we are doing a square here. So square root of this is 5 and this is 6. So will the relationship hold true? Whatever relationship you have with parent, in the previous case, which is hold true now? It will hold true. So do we really need to calculate the square root and put extra pressure on the system? No, right? That is the catch here.
Okay. So coming to your point, so you were telling that root mean square value is directly proportional to score.
So you'll ask me, how is it getting to that 0 to 1 range?
No. What I am asking, okay, removing root, so mean square error is directly proportional to the score.
Right. See, in every case you will get things which are varied from all, but it is few things like how to calculate area of a circle, right? Why is area of a circle pi r square, right? So it is like small. You break down the circle into small piece and it will become a rectangle. Okay, where one side is r and the other side is pi r. Right? So if you see, these are like continuous mathematics. That is where integration calculus. I'll talk about calculus also in calculus. Okay, so you'll gradually understand many things. But the idea for actually doing proper machine, you really don't need very deep knowledge, because it is infinite. I mean, it is not possible to understand. Okay, but you need to ask questions so that it is clear to you at every stage. That is understood, right? Why these things are different and why this is the maths here. Few of the things like 1 by 2m, because they want to normalize it. There is a term normalization to make something, something which can be expected by the entire system normalized. Like whatever number you get, you want to normalize it between 0 and 1. You will divide it by some number and it will normalize it. For doing that, you use 1 by 2. Actually, the benefit of 1 by 2 is if you do calculus here, d by dx of this entire thing, which I'll show in gradient descent, okay, which will help you understand this.
This formula is integration, right?
This formula No, this formula is normal. The gradient descent formula will come from integration. I mean the final output. So it's clear so far. Do you want to take a break or it's fine? Let's wait in 5 minutes.
Integration. We have to study.
No, don't worry. These things are what is differentiation? What is calculus? Like calculus is rather differentiation is that is one thing, but it is a measure of change of something. Okay, that is differentiation. I mean, what do you say? If you have a curve, if you have to find a tangent at a particular point, that is your d by dx, right? That is rate of change. Anyway, these are simple things we'll cover. Wait after 5-10 minutes.
when you just
Journals.
छोटा कम छोड़ गया तो बोले कैसे होता बैकग्राउंड बढ़ गया इतना पहले ना मतलब at least step by step rules maximum and the school business. This is not right. That's not right. That's what going to be right now. To bullying for the question is. So there were article over the original side. I think this is the equal for the state. What for it? Let's see what I do.
You are from which company? from which country? From here. And what's your name? Sorry, I asked you wrong question first time. Okay. What's your name? Asupos. My name is Pratyush. Hello? Pradyumna. Very good. What's your name? Something related to yes.
The online payment gateway, there is a concept. Visa secure version like Visa secure.
Students. Mostly to have development of the government. तुम्हें लोडिया अच्छा समझ पहले लोडिया था हमें कहीं नहीं नो एलजी एलजी साहब तुम्हें भी ये बैकग्राउंड थो कि मोस्टली मशीन लर्निंग और
No, only a data version background. This platform का मौका हुआ.
कॉम्बिनेशन माने साइंस तो नहीं नॉर्मली पढ़ा हुआ वो अच्छी प्रोजेक्ट मैनेजमेंट किसी भी डाटा को एनालिसिस करे ऊपर तो मैं ଟିକେ ବେଶୀ देखता हूं ତା ପୂର୍ବରୁ ମୁଁ ଥିଲି ଏଠି ଡିଜାଇନ ସଲ୍ୟୁସନ୍ସ ପାଖରେ ସେଠି ଡାଟା ଆନାଲିଷ୍ଟ କାମ କରୁଥିଲି ସେଠି ଗଲା ପରେ ସେ ସ୍କୋପ ଆଉ ନାହିଁ ତ ବସ୍ ଶିଖ ବାହା W ମୁଁ ଜାଣିଛି ହଁ ଶିଖିବି ଏଠି ବି କାମ କରୁଛି। Python में hands-on ଅଛି communicator भी Python बेटा କିନ୍ତୁ Python ରେ ସ୍କୋପ କେମିତି ଅଛି
स्कोप सब
what data
डाटा साइंस Python भी ଅଛି R भी ଅଛି ଆମର ଆଉ
କଣ ହଉଛି
OC ବି ଅଛି
Requirement देखो combination
हमने बात है तो
खूब मार्क्स
और मुझे इंटरनेट करने के बाद और रूम पे क्लास चले तो सिर्फ
तो जैसे ट्रेनिंग कोई ଆମକୁ ସେପଟ ଟିକେ ଆସିଲେ ସେ ଆମ ଟିକେ ଆସିଲେ ନାଇଁ ତାହେଲେ ହଁ ତମେ ତ ଆସ ତ ରେଡି ଗୋଟେ କୋଉଠି ଆସି ଏ ରେଡି ଗୋଟେ ତମେ ମତେ କିଲା ଷ୍ଟାର ବଜାର ଉଠେଇ କାଢିବ କୋଉ ଷ୍ଟାର ବଜାର ପକେଇ ବସିବି ଏ କୋନା ଲେগে ଓ ତମେ ହାଇ କରୁଥିଲ ସିଏ ଆସିଲା କାର୍ତ୍ତିକ ବାବୁ ସେ ସନ୍ତର ହସ୍ପିଟାଲ ଦେଇ କୋନାରେ ପହଞ୍ଚିଲା ତାକୁ ତମେ ଆସିଲା ଗେଟ୍ ଖୋଲିଗଲା ସେ ପାଣି ହସ୍ପିଟାଲ ବାହାରେ ଖାଲି ଯିବି तुमको सीधा आस्ता तो
ना से
बड़ा कोई भी क्या करता
ना से सही लोग
तो बड़ा लगे तो चिकन गार्ड बसे अल्लाह वो जो बड़ा लगे तो को काटी को इसी स्टोर होता इसी में तो रोड क्रॉस कर लेंगे रोड क्रॉस करके तब जाना मुझे चिकन गार्ड तब कुछ तो ठीक तो 15 हम से की बात ना होगी देखो आपको बड़ी सी तो सही काय करना उसको तो सीधा बोलते हो तब ये समझ सकते हैं yeah
yeah, I'm in a session now. We can talk to you a little later. Even on the yeah, 6 o'clock. Sure, thanks. Yeah, all fine so far. Oh. Hi, I didn't ask you any questions. So, you have any questions, Subrat? Oh.
Hello.
Do you have any questions?
Hello, Avantik.
Yeah. So
No, nothing as of now. So maybe I'll re-listen this recording. So maybe tomorrow I'll
Sure. Do that. And
yeah. Okay. Yeah.
do that because it needs multiple iterations. I mean, there is no shortcut to that actually. Okay. Feel free to ask anything that you feel like. It's like
Yeah.
Okay.
Yeah. Sure.
So just a second. Is Gaurav's voice audible to you? You speak. I just want to check.
one person can you hear me
I can hear all of them, but not as clear as yours.
Okay. So so feel free
Yes.
to speak a little louder so that you can benefit from each other's questions.
so here the question is like when you try to deliver so in the test data only we will be getting the theta 0 or theta 1 value right so let's say on the 80% on the training data we have a model and we say that line this is correct on the best fit line now you are going to do the testing on the 20% data which is the test data and you got so in the after doing a test you will only receive these two parameters right theta 0 and theta 1 right or that what automatically linear regression model will find a line and give it to you how it comes how to compare
Right. So as far as there are multiple things here. Okay. Now suppose you have a very simple y is equal to mx one simple equation. Now you can possibly have one more expression. You can have a quadratic expression y is equal to ax plus bx square plus c. Right? You can have an equation like that also. That will call it. So now you have to compare which one is better. Right? So both of them used 80% of the training data set and figured out this is the best quadratic equation. This is the best straight line equation. Now it is up to you which one to choose. To choose to select which one among them is better candidate, what you do, you use test data set, the 20% of the data set on both of them. See what is the score, and based on the score, you predict this y is better.
okay now another let's say you did the linear equation of one variable one feature okay but I want you should have used the other features let's say you have used 3 features but my expectation is like you need to use 5 features and give it out
Right.
3 features output is different and 5 features output
Right.
on that
case you'll do the same training. It will go the same. Training the way we give one feature here, you give multiple features, and finally when you have that model ready with 2 features.
okay so 5 feature means 5 equations
No.
It can be different. You can create 5 equations or you can by combining them you can create one.
Right.
So let's say you combine all the 5 and give me one equation.
Right.
And I am doing the testing on the test data and I took 5 different features and came up with another equation. So this will not be same. Right?
This will not be same.
But on that case, which are the dimension reduction attributes you have been, I need to use the same.
No. Wait. So you forget about feature selection now. Okay. So you somehow chose 3 features in one model, 3 features in one model. This line is clear.
One model means okay.
See, one model means one. See, you are using 3 features in one hypothesis function.
Okay. One function.
You are using 3 features. Another 3 feature, different 3 feature, or say 2 feature in another hypothesis function.
Okay.
right? You calculated the model here.
Correct.
I mean, two models you calculate.
Correct.
Now you have to tell him, which one among them is better, right?
Okay.
So for that, what you do, you have to use score, and you have to pass both of them the test data set, and it will calculate you the score. So, and whichever performs better is a better algorithm.
Okay. Score is 0.79. So which is close to 1, that is best. That is the point, right? So that is common.
That's it. Clear, right? So you have multiple algorithms. You have to choose which one works best.
That is the way I can do it. Yes. So I might have 4 equations, but on the test data, I'll just fit the test data to 4 equations. Whichever score is close to 1, that is the best one.
That's it.
That's the point.
That's it. Okay, so
in regression part, in the analysis, like we should only consider like interceptor cut by MX plus C, as well as quadratic, as well as vector. Like that, all the conditions will need to satisfy for cross-check or
right. So
Right, good question. So, what do you do for this, right? I mean, which the apparently your question is, how do you decide like which linear which expression to use? Should it be quadratic? Should be raised to the power 13? Should be raised, right? Which type of thing? Because for that, everybody you have to create a different model, right? This is where your dimension reduction things come into action. This is where you will. This is what a data scientist will do. Okay, you will use different models and try to find out which is the best model to do this. Okay, you'll actually, now that actually logically connects to the next step. Okay, next step is, I'll show you now. Okay, so this part is clear to you, right? You got cost. Now I'm coming to your question, and that is what my next topic is. So automatically it's falling down there. So now see this curve. Okay, what is your j theta? J theta is your cost function. Okay, for different theta 1, assume that for different value of theta 0, theta 1. So theta 0 as of now you have taken it constant 0. Okay, now what you are doing, you have to calculate which model is best for you. So theoretically answer, which model is best for you? Score is close to 1, or in this case you should imagine it's reverse. We are using RMSE, right? Your understanding is 0. It should be close to 0. So what you will do here, you will find, okay, you will find score for all the models, or the RMSE for all the models, and put it in a graph, right? So how many such models will be evaluated for a particular problem? Huge, right? You will have millions of models which will be fighting for best tag, right? So you will plot a graph. Okay, this is a very simple 2-dimensional graph. Actually, later on you'll see it getting as complicated as this. And trust me, this is not complicated. This is just 1 degree more than whatever you saw. And after that, we can't even see. We have to just imagine. So yeah. So what you have to do? This is your j theta. J theta is a cost function, right? You have to plot a graph for all the different models. Right? What is all different model? One model is with theta 0. Okay. One model with theta 1 is equal to 1 model with this guy. Right? So you have all the different models here. Right? So it has to now it projected a graph. Okay. And you have to find out the point in the graph which is closest to 0. So the graph, this is like this. So graph actually can be like this and like this. Okay. You have to find out which is the bottomest point in the graph. Okay, which is the point at which the cost function is minimal. One such popular way to do this is gradient. Okay, so what is gradient descent? It is a mechanism by which you can find the lowest cost point. I'll come to that. Okay, so just see this case. This is our hypothesis, taking a very simple example. This is the parameters, right? This is parameters M and C, the parameters. This is the cost function, right? For each theta 0, theta 1 combination, this is the cost function, right? And what is the goal? The goal is to optimize the cost function. This slide should be very clear. Right? This is the crux of linear regression in a simple case.
Can you share this?
Of course. So just take this example. This diagram. Just see this diagram. I'll come back to whatever this is. So understand that there are two variables now. Theta 0, theta 1. This is two variables. Okay. So what that means? These are your j theta 0 theta 1. What is j theta 0 theta 1? Cost function for a corresponding theta 0 and theta 1. You projected for every theta 0 0 and created points and you need because you test. That's what your machine learning algorithm does. It actually stores all the data. That is why it needs huge data. That's why it needs too much computation. We tested actually for all possible values of 0 and 1. That theta 0 and theta 1. Right? It used that and it found out such response. Which is the theta 0 theta 1 that will be used as a final model? The one which is lowest to this is 0. Okay? This is 0 axis. So which is lowest? Just imagine this is hill. Okay, and we have to find out or I don't know how to imagine. Yeah, you imagine this is island. Okay, you have to find the point which is closest to sea surface. Right? That is what you have to do to find a point which is closest to sea surface. So, assuming that island is not connected to sea surface. Okay, so you have to find this particular point. Right? So, from the process of doing this, there are various algorithms. Gradient descent is one most popular way. Okay, understood. What is gradient descent? We'll calculate it. So far, everything is clear, right? J theta 0, the notations and all.
So gradient descent is also supervised.
It is not supervised. It is, suppose you have a, it is actually coming from mathematics world. Okay. What you have to do here, you have theta 0, theta 1 and it's a j theta 0, theta 1 function. Okay. You have to find, and for each theta 0, theta 1, what is each point, right? Yeah. So for this, there is one point here, right? For theta 0 is equal to this, theta 1 is equal to this, right? This is the value of j theta 0, theta 1. Okay. For theta 0 is equal to this is the value of this. Now you have to find out which is giving you this j theta 0, theta 1. Right? So we are asking,
my question was how it is different from the linear regression and on which case we have to use this one.
See, no, in which case it is used by linear regressions. This is internally used by this algorithm. Okay, to find out which is the best one.
What are getting the final value, but internally what is happening?
See, we quickly did one function and our result was there, right? Internally, it is using gradient descent to identify the minimum cost.
So for finding the cost, this methodology has done.
So when you are, see that if you know mathematically, okay, this is what it is, and there are a few other algorithms. Knowing it little deeper inside will help you choose, right? That is, so you typically know here, okay, this is where gradient descent is. There are little pros and cons of using this.
So either any other algorithms inside apart from linear regression, apart from this gradient descent?
Yeah, there are few algorithms.
Okay. Now the next question is
why this is better.
Why this is better?
Yeah, so this is better and most used in machine learning because for linear regression because it maps the test case. So what there is something like statistic gradient descent. I mean, this is some variations of it. Okay, some versions of it. Now that particular, I mean, based on a lot of tests that has happened. Okay, I don't know all the tests that
Maybe
So maybe a lot of tests that have happened, people have realized this is better. Oh, okay, that is good. So
this is universally accepted.
This is universal.
All linear regressions, this is universal.
I mean, if you are going to next level, some specific problem for which these things are not best. Do this. There is a long curve, but more or less, this solves all the purpose. Okay. So I'll come back to code. Okay. So let's add one more feature. Okay. Now,
so you'll be telling in detail about gradient descent? Or?
Yes, the gradient descent I will get a little deeper. Okay. So that we are able to understand how to measure that. Okay. Just to a certain extent, so that you feel comfortable talking and hearing about it. Okay. Let's do something more in coding, then I'll come back to it. Suppose you want to predict. Now your model is ready, but what is the use of model if you are not using it for prediction, right? If you want to predict what will be, my cost of pizza, which is of size 12. Okay. So all the test cases should be like this inside. So 12. Okay, give more, right? Whatever you give it. 12 is size of pizza. Because I'm going back to the problem. So what you're trying to do here, you're trying to predict the price of pizza based on the size using our model that we have learned. Okay, so using this, it will actually predict it.
And what is the score for this model?
Score for this model is this guy, 0.59.
That's why the value is coming less. If the score will then this 13 may come around 50.
Not necessarily. It may come down also. So right, it will be more precise. Yeah. So but don't generalize so early, because we are using very less data set. Okay, because in fact in less data set, machine learning is worse than human prediction. Right. So right. So you cannot. In this case things may go wrong. Okay, but just for understand. Okay, so. So what we can do is, like, this is a data. This is how data is generated. Test size pizza. So I've generated data from 10 to 50, right? For some projecting the graph and everything, right? 10 to 50 with separation of 2. These are different sizes. I want to test for this guy. So what I'm doing, and this is the price which is predicted, right? So what I'm doing here, I'm plotting this is a straight line. So I'm plotting the price, plotting the size and the price, right? So this is the prediction, and I'm plotting size, price, and M the magenta for color. This line is clear. Line number 91. Line number 89.
When did you get this station underscore pizza?
This one.
Inside predict.
It should be size, right? Yeah, it should be size. And the intentional pizza is coming from above somewhere. Right. This is using this guy. So he's actually plotting it for size, and right. It uses this data to predict the price. I think I changed it already. Size. The value was right. There's that. I think I changed it. Right. This is your graph plotting it.
Before whatever it was, test underscore pizza, it was a total data frame value. Right.
Which one?
It was taking test underscore pizza.
This one you're seeing, no? See, this is this one. Or you want me to go into
See, test underscore pizza is a data frame.
Right.
And whatever value you have given, that is the test underscore pizza. So the model was taking the value of a data frame, not a series. So how it was calculating, I don't understand.
Yeah. So in this case, when I'm using this prediction, right? I'm giving test pizza size. So what is it? Data frame. Right? What is it? Data frame.
But it is a single column.
Single column.
But then that is it was.
See, in that case also it is a data frame because I'm giving double bracket.
Yeah, it was data frame, but it was having two columns, right? Size and price.
In that case means when I
Test underscore pizza.
When it was that case, I think this was some typo. Yeah, so but that's pretty much.
It's okay. I just wanted to know how the model was calculated because I didn't see any change in the graph.
No, I think I was doing some, because it should be like this on earlier case also, right? Because you have, what is the data point? You have 10, 12, 14, this was the data point, right? 10, 12, 14. So graph was for right one only.
And we separated by 2.
Separated by 2. The graph was right. For some reason this was not right. Maybe I was trying to manipulate some.
Graph is for price and size, right?
Price and size. This is your price, this is your size. It's saying this, right? See, this is an error. The earlier case, right?
Okay.
That was an error actually.
Okay.
That's what.
Somehow
right.
it
Good.
was
Right. Somehow it got. Yeah. Okay, because it cannot take that entire thing, right?
Yes.
Clear, right? Or we are projecting here. So now that we are done with single equation, we can actually make it better by taking more variables into consider, more features into consideration. So now we have one more data set, toppings. Okay, this is our data set now. We have size, toppings, price. 3 data sets here. Okay. So now what you are doing, same stuff. We are using 2 features now, size and topics, right? In training the data set. Okay, and you have the price here. So now this is our test data now. Okay, test data consists of your it's a little overlapping, a little different. This is the data set. Now we are testing with a new feature, one more additional feature this time. See the score where it has gone up. Okay. Okay, but not necessarily again this will be right because small data set. But generally you will see improvement in score if you add more features. But I have a caution, there is no thumb rule here. Right? You have to figure out till what it works fine. You have to figure out when it stops working. You have to find the best match there.
Even some cases happen that if we increase the data set number also, the price will, the score will.
Exactly. If it is your increased data set number, okay, and your model is actually overfitting. So actually that it will deteriorate with time. Right? Okay, and you are predicting the stuff here.
Interchange. See, it's based on the score. See, centers for static. The score is a like
for Skykit, yeah.
So the score is dependent on the axis, like as per your earlier equation, y equal to b, beta 0, beta 1, x. Beta 0 is a like x coordinate as a 0. After that, it is static. So y coordinate is like here is a topping point. As per
no. In this case, when it is 2 variable, like you have 2 features here, right? It becomes y is equal to beta 0 plus beta 1x plus beta 2x2, where x1 is your size, x2 is your toppings.
Y is price.
Y is price.
So what is beta 1?
Beta 0, beta 1, beta 2 are coefficients. Beta 0 will be your intercept. Okay, and beta 1, beta 2 will be our other factors, which will be cosines. You have line A is equal to bx plus c. X is equal to ax plus by plus c. Simple equation of our line, right? So because there are 2 features here, right? 2 features. That is why it is called multiple linear regression. You have 2 features.
Okay, so x represents both the arguments.
X1 will be your size of pizza.
No. Mathematically.
Oh, sorry.
X1 or x2 is representing both x and x1.
No. Now this is no more two-dimensional. Now it becomes three-dimensional. Okay, where you have y, x1, x2. Right? It becomes three-dimensional. Y is one axis, and you have x1 and x2. Now, based on x1 and x2, you are predicting. So it will be in some hyperplane.
For example, side is for x1, stopping is for x2, right? Side is for x1, stopping is
for x2.
And error we are not taking into account. Error term we are not taking into account.
Error term.
MS plus constant value.
Constant is beta 0.
So then what is that epsilon?
This is it. So then don't worry about end, right? Yeah. So end is some more constants, I guess.
Yeah, that constant we are not taking into.
So not into. This is actually I wanted an image.
Multiple.
No. There will be one constant, but there can be more environmental factors as well. Okay. So don't worry much. It will generally look like y is equal to ax plus by plus c.
So in that case, there is no beta 0 value.
No. The beta 0, beta 1 is just constant. These are c. When you have to define a line, right? Y is equal to c. Let's forget about c. Let's use beta 0 since I wasted beta 0. This is one constant. Okay, this is one more variable. This is a feature. This is a variable. This is a feature. So forget about the other things. Suppose this is the equation now, right? What your model should do? What your model should figure out the best value beta 0, beta 1. And I think this is theta 0, theta 1, and theta 2. See, the reason why I have to paste this is because I wanted an image here. The problem that I face here is I don't know how to write these notations in this GitHub. Okay, they don't have any mathematical notation writing stuff. So I have to find images and embed it here. That is how it works. So I have to create images, which is a time-consuming task. But yeah, don't get into this. Just understand this is beta 0, beta 1, beta 2. These are your features. These are the constants that we have. Clear, right? Yes, the constant. So that is the multiple linear regression.
Job is to minimize constants.
No. Job is to minimize the cost. And find the best constants for which the cost will be minimal. Same as what we did before, right? It does figure out to find the best combination.
cost minimum score
right? And best combination of minimize the cost.
Okay, I think we forgot rescheduling the next class. Okay, it is overlapping now. Okay, so then I took it from tomorrow. It will be 8:30 to 11:30. Okay, so yeah, other people are waiting. Okay, so far everything's clear. Very clear. Huh? Yeah, let me know. Yeah, I don't know if you find a tool to create this expression. Let me know. I struggle a lot. I mean, it's easier to do on board and all, but you don't do permanent application. So there is that. So get your laptop tomorrow. We'll do this.
Did you try with MATLAB?
No. MATLAB have this. I can use the image from there. I mean, I don't want to store the screenshot, store it for later. That is too much time taking. I want shortcuts, so I don't know. I have to check this.
Recording will be shared.
Just
stop it.
Yeah.
Honestly.
Hey, Subrat, we'll be stopping now.
Yeah, one thing. Yeah.
Yeah, I'll upload the recordings in YouTube and send you all the link. Okay.
Okay. Thanks.
Yeah. Thanks.